I'm John Cobb. I teach here in Claremont at the School of Theology and the Claremont Graduate School. I'm also director of the Center for Process Studies. And we're very fortunate at the center to have had Professor David Bohm visiting with us now for several weeks. And we are happy today that he can join me in the conversation here. David Bohm is a leading theoretical physicist who teaches at the University of London. He's recently written a very important book on Wholeness and the Implicate order. David, I've heard you say in recent conversations that around the end of the last century there were people who felt that physics was just about finished, that everything that needed to be known about the world was already known. And yet today we find an explosion in all kinds of directions. What's happened in these intervening decades?
There have been the two big revolutions of relativity and quantum theory, which totally overturned the concepts of the 19th century classical physics. And since that time, we've gone on to the discovery of nuclear physics and elementary particle physics, and also extending physics into cosmology and into general relativity and black holes and the notion of the beginning of the universe. And it has really unfolded in a vast number of ways.
I think you had some personal acquaintance with some of the key figures in reshaping physics, didn't you?
Well, I knew, I knew Einstein and a bit, and I've talked and discussed with him several times. We had a correspondence for a number of years, and I've met people like Niels Bohr and Pauli, and of course I knew Oppenheimer fairly well.
In what ways did Einstein's theory shatter the earlier worldview?
Yes, well, the most fundamental way, there are several ways in which it shattered it, but there are probably two most fundamental. One was to change the notion of time, that time is one of our deepest feelings and thoughts, and the idea of a common time, common to everybody, was what was changed by Einstein to saying that systems moving at different speeds would have different kinds of time. They always used to talk in terms of observers moving at different speeds, but I don't like that terminology. I would rather, it's an objective fact that systems moving at different times have different kinds of, not only different rates of time, but they disagree on what is meant by what is the same time.
But I think I've heard you say that quantum theory has even more radical implications.
Yes, because quantum theory shatters the notion that motion is continuous and that you can uniquely define the nature of a thing apart from its context in which you have to observe it. And thirdly, it introduces a property of non-locality, saying that things can, in a certain way, affect each other over long distances without any of the ordinary force of interaction. But the effect is very peculiar in the sense that it depends on the state of the whole. The way the parts affect each other depend on the state of the whole. It's what I meant when I have said that the whole actually organizes the parts.
And what does that mean about the whole? That it is another part alongside of the other part?
No, it means the whole has another quality, and that if we think of, in some sense, if you think of the whole, that the relationship of the parts changes according to the state of the whole, and the whole has a certain meaning which goes beyond that of the parts. Whereas in a mechanism, the only meaning of the whole is the parts and all their relationships. Now the whole seems to have more in it than that, and that you can carry it so far as to say that even that the whole creates the parts in a more fundamental theory.
Now when you say the whole, you might be referring to something like the molecule creating the parts of the molecule.
No, in the molecule, the present theory would be that the whole that state of the whole molecule organizes the parts.
So when you say the whole creates the parts,
I would
be the entire whole.
The universe, the whole universe, the field of the universe, the whole creates the parts which are to be found in that field.
How does that show up in contemporary physics?
Well, it turns out to show up in a way that is at first so abstract that it is in mathematics very difficult to describe, and that is perhaps one reason why there's so little awareness of the startling consequences of this theory. That one says that the whole is described in a multidimensional space by a wave function, it's called. And one sees that in describing a whole molecule, this description of the whole precedes the description of any of the parts. And in fact, it affects fundamentally the way the parts are going to be related. Now, the nearest situation to that would be, in human experience, would be to say the state of a whole group of people affects the relationships of all the people in it in a way which cannot be deduced from those people considered as separate.
When you take a whole group of people, couldn't you possibly understand that the interrelationships among them are the explanation of this phenomenon of the whole? Couldn't you understand that each of them is experiencing all the others in such a way that they are different when they are part of this group than they would be under other circumstances?
But you see, the question is, if you start from those people as separate, all this is merely a potential, you see. Now, when a whole comes into being, then this whole, which depends on the state of the whole, organizes each of the parts. So if you wish, you could try to say that since each person within him contains the whole, he is a different person than he is when he is separate. Right? Yeah. But he is, and therefore his relation to all the others depends on that whole. But the existence of that whole is what therefore makes that person, each person, what he is, and all the relations what they are.
You've used the image of the holograph. Do you think that helps in understanding at this point?
No, because the holograph is a very limited image. It's an analogy. See, it's just what the holograph does not do. See, the holograph shows the enfoldment and unfoldment of each part in each other. What it doesn't do is to show how parts are actually organized. You see, that is, in the holograph, we take for granted the organization of the parts, and we merely make holographs of it. We assume various objects which are hologrammed and then be shown. Whereas when we come to quantum mechanical field theory, our problem, see, if we discuss it merely in the classical level, the fields can enfold and unfold and so on, but there's no stability, no particular organization to it. It will hold any organization, and they all tend to fall apart as the waves spread, right? Now, what we have to do is to explain that actually within these waves there are particle-like properties which are constantly maintained. And this, it is the state of the whole which explains how they are maintained, and the quanta, that the whole contains parts, is essentially, which are stable and relatively independent and so on. This is what comes out of this feature of the quantum theory.
Now, when you speak of enfolding and unfolding, sometimes you're referring to the way in which the single unit within this whole is enfolding the whole
yes.
and unfolding, but you also think of the whole, in the broadest sense, as enfolding everything and unfolding into everything.
That's another way to think, yes. You see, I think that there are several ways that you see. One can think that there are several levels. There are three ways to think. One is to think of just the whole enfolding and unfolding. Another is to think of several levels of implicate order. I can give the example, say, of the television screen, the computer game with the screen, which is in which all sorts of forms can unfold, and the program which determines in which ones are going to. You see, so the thing is, the first implicate order of the screen is organized by the second implicate order of the program, and that may be partially organized by the programmer and so on. That is, one can think of a series of levels of implicate order. And also one can think of some still more encompassing implicate order which enfolds them all, and from which, in some sense, they all unfold, you see. That is, there are various levels of thought you can bring in to try to grasp aspects of this. But I say ultimately the thing would probably go beyond what you could grasp in any thought, because it has infinite potential.
And does potential belong to the implicate order as over against actuality belonging to the explicate order?
No, well, you see, the explicate order is not different from the implicate order fundamentally. It's a particular form within the implicate order. It's just that the potential, if we look at any, that the if we only look at the explicate order, then we must understand the deeper implicate order as the source of the potential, right? Now, we can look at it the other way and see that the deeper implicate order also contains within it a reason why it will form an explicate order.
And how do you relate the deeper implicate order to the whole?
Oh, well, yes, you see, I think here it's a question of language. That what I mean by wholeness, you see, I don't think we ever captured the whole. Rather, there's the quality of wholeness, which I want to emphasize. And wholeness is, first of all, unbroken, seamless wholeness. Secondly, internal relations of elements. And thirdly, the fact that that wholes are organizing the parts. These are parts of the qualities of wholeness. They probably could be extended. That it's really the quality of wholeness that I have in mind rather than the whole. You see, because I don't know that the whole could ever be defined.
So when you say that the whole creates the parts, in some sense it's the quality of wholeness
yes.
rather than the universe as a whole.
Yes, I want to say that that is characteristic of the quality of wholeness. And if we were to analyze some aspects of it, then we would see some relative whole creating some relative part. Right? As in the case of an organism, or in the case of the electron, or somewhere in the field.
Now, you derive most of this from your reflections on quantum. Can you relate it at all to the relativity theory?
Well, that's what I'm trying to do. That, see, I think that relativity introduces wholeness in another way through thinking of the universe as one field which is unbroken. So it strongly emphasizes the notion of the seamless whole, but it strongly also emphasizes the notion of parts through its idea of signals not being faster than light. And the idea that there is a signal is already, that it is that definite, that it has a definite meaning, is what enables you to define the parts, right? Now, the quantum mechanics doesn't limit you to the speed of light, but it does so because the connections are not in the nature of signals, but in the nature of something too ambiguous to communicate that definite a message. And therefore, it means getting beyond the context of relativity. You see, the context of relativity is the context in which signals can be defined. Einstein really clearly put it that way. Now, I think quantum still has meaning, but it's the notion of meaning beyond meaning with ambiguity. And all fundamental meaning has some ambiguity, and that nevertheless it still means something. You see, that this is a way which is hard to put in physics, because physics is always aiming at something unambiguous.
And these subtle and ambiguous meanings nevertheless have the power to bestow some kind of order on it.
Yes, that's right. And I think in your experience in consciousness, you can see that the most fundamental meanings are ambiguous too, that it's only a special case to produce relatively unambiguous meanings, which are highly explicate. You see, the implicate order is ambiguous, another way of putting it. That's why you call it potential. And it depends on context, what's going to come out of it, you see. And now, I think our whole recent past has been such as to condition us heavily, in the last few hundred years, to the notion of unambiguous reality. And I think this was really Bohr's very basic point, which Einstein never appreciated. See, the disagreement with Bohr and Einstein was the question that Bohr talked of ambiguity and Einstein talked of a signal, which means unambiguity, and that was what they were fighting about.
I know you're personally very interested in questions of religious meaning also. Can you relate what you've been saying about wholeness and about the implicate order to questions of ultimate meaning?
Yes, well, well, first of all, of course, that everything is we are enfolded in everything in us, that the meaning depends. If we say we're all separate, that's one meaning, and in fact that is often called meaningless. It's not true to call it meaningless. It's just a meaning that we find uncomfortable, don't like, right? It doesn't appeal to us. Right? It seems rather trivial. And the notion that we're all enfolded in therefore that this meaning is the very essence of the universe, but and us. But the attempt to define it is going to be limited, right? That is, rather than define it, it has to be actually that life is the meaning, rather than something that can be stated, right? Now, but the question or the nature of life will depend on what we think about it, because if we think everything is separate, we're going to produce a certain way of life in which everything means separation and so on. And now, I think that if we were starting from another way of thinking, this would open up the possibility of being related in a different way. For example, the problem of communication. As long as people feel themselves as distinct and separate entities, they're going to feel that they're very vulnerable. They're going to try to defend themselves and their ideas. And there's going to be a lot of conflict, you see. Now, if they don't feel that they are separate and so on, I think the whole feeling will be different. You see, it's the same thing to say that if I have a toothache or pain somewhere, I do something about it. It's not to say, well, the brain says I don't care. It's just the tooth that's aching. You see, but of course we don't feel that way if somebody else is suffering. You see, now if we could feel the same way about somebody else's suffering as our own, we would quickly do something about it. But since we don't feel that way, especially when they're conveniently far away, we can very easily do nothing, and the whole problems all get worse, right? So, you see, this feeling that we are separate individuals means that we are not going to solve the social problem. We don't really have a strong impetus to solve it. In fact, we have rather a strong impetus to avoid it, solving it.
And you're suggesting that this feeling is in part a result of the way in which we've conceived the situation.
Yeah, that's right, yes. See, so that we've conceived it as all separate, and the way we feel is heavily affected by the way we conceive it. That's the unfoldment between thought and feeling, you see. That thought unfolds feeling, and feeling unfolds thought.
And when we begin to think differently, will that quickly change?
Not necessarily, but it's part of it. You see, thinking, if we fail to think differently, our feeling will not change. I'll put it that way, but more may be needed. That is, holding to our present thoughts will hold our feelings the way they are. So letting our thoughts change is a step, you see. But for the feelings to change actually may require more. It may require awareness of the feelings and of the connection of thoughts and feelings, and attention to that as well. The feeling, thought alone is not enough to do it, but without thought doing it, it will never happen.
You've emphasized our unity with other human beings. Do we have also a connection to the rest of the world?
To, what do you mean, to animals? To
animals?
Oh, yes, I feel...
The inanimate world?
Yes, I think that the animate world enfolds us, and we have come from it. See, we are the inanimate world. We have arisen, it has organized itself into us.
Thinking that thought also have an effect on the way we behave?
Yes, we would treat matter with more respect. You see, at present we regard matter as something to be exploited and used for our convenience. You see, but you would not say, I'm going to use my arm or my tooth or my head for my convenience, you see. You see that some people may do it sometimes, but the point is that if we say there would be no division between the sacred and the, what do you call it, the secular, that ultimately it is all one, right? See, therefore we would treat matter with the respect which it should be treated, you see, that, and therefore we wouldn't be destroying the resources of the planet and polluting and doing all that. You see that, or no, we would be producing ugly configurations of matter in the forms of buildings and other things. You see, I think that we would look at the whole thing, that if something is out of order anywhere, we would feel it as in ourselves just as bad as if something is out of order in ourselves. And that you would feel an immediate impulse, you must do something. Right? Now, we don't feel that now, right? Generally speaking. You see, therefore we don't feel responsible for what's happening somewhere else, you see. Now, see, the point is there has to be a feeling of spontaneous responsibility of each for all and all for each. That requires a different way of thinking. As I said, a different way of thinking alone is not enough.
And would you call that a religious way of thinking?
Yeah.
And because to be religious is to be overcoming fragmentation, and dividing things together.
Yes, to make them whole, right? To heal them, too.
Yes. Do you see any signs of hope? Are there any ways in which these new insights of contemporary physics are beginning to change the ways people think about themselves and about the world?
Well, I think it's early days to say that. You see, that is having some effect, I can see. It must have much more. I don't think physics alone can do it. I mean, I think it's only a contribution, you see, but to the whole. But I see more signs here and there that people are awakening to the problem. Unfortunately, it's a race of time because, we are faced with a catastrophe which may be developing very rapidly. That is, if things were moving at the pace they moved 50 years ago, I would be a great deal more confident.
Well, thank you very much, David. I think you'll all agree with me that we've had a very rich experience of hearing a wide range of ideas. I hope that they will be significant to you as they have been to me.